significant hurricane impacts on the U.S. mainland. Nothing really much in the Caribbean Sea this past season. Looking at our forecast from early June last year, we were looking at about 12 named storms, 6 of them hurricanes, and 2 major or intense hurricanes. The area that we highlighted in red there was where we thought they had an enhanced chance of impact. And the area in blue there from the Dominican Republic through the eastern Caribbean Sea, we thought we'd have less than normal activity in those areas. And we take a look at the map from last year. You can see that all the hurricanes and tropical storms that impacted the United States did strike over in the southeastern U.S., one across western Cuba, that was Michael, and not much activity over in the eastern Caribbean Sea. We had Alberto, Gordon, Michael, and Florence striking the southeast U.S., and over toward the eastern Caribbean Sea, we had a weakening, in fact, the dissipating tropical storm Kirk and tropical storm Isaac both impacted the central islands there. Not much activity in the way of winds, a little bit of rainfall, but no significant impact there. Good news because they were very, very hard hit in the 2017 hurricane season. Now, let's take a brief look back at Hurricane Florence. Florence became a major hurricane out to the south and southeast of Bermuda, but by the time it reached the east U.S. coast, it had weakened considerably to a Category 1 hurricane, still at 90 miles per hour at landfall, but it did produce some very, very heavy rainfall. Now, the forecast for Florence early on there out well southeast of Bermuda differ between our forecast, our full 7-day forecast, and the Hurricane Center's forecast over on the right. Now, the Hurricane Center at that time was indicating that Florence would most likely turn to the north and track on out to sea east of Bermuda. Our track was a little bit different, taking it south of Bermuda and indicating a potential threat to the mid-Atlantic coast. Now, you might ask, well, how could 2 agencies have a different forecast? Well, let's take a look at the model guidance that existed at that time. And I think you can see from this model guidance that it's pretty clear where Florence was going to go, right? Right, Dave?
Yeah, clear as mud.
Yeah. So it's pretty clear where it's going to go. So how do you determine when you're looking at this? And this is just 94 different model tracks here. I took off all the other hurricane models and experimental models here. So we may be looking at 120 different model tracks and trying to figure out where these storms are going to go. One of the tools that we developed in the past several years is called our track guidance, our threatened region from active cyclones, which takes all those tracks and consolidates them into basically a probability map, as you see here. That's those same tracks you saw in the previous slide, and they indicate that more likely the storm is going to track to the south of Bermuda, perhaps threatening the east U.S. coast. But there was a kind of a divergence. Some of the models were indicating a potential turn east of Bermuda, and the Hurricane Center is looking at the same models, and they were just more gradually adjusting their track westward on that September 5th day. Now, taking a look a couple days later, by that time, the track guidance is getting set on North Carolina, somewhere near Wilmington for the landfall in about 6 or 7 days. That's eventually where it made landfall. What it wasn't predicting quite yet was what was going to happen after landfall. You can see that a few days later, that the models were now indicating it tracks right up here, very near Wilmington, North Carolina. But then it moves west-southwestward and moves through northern parts of South Carolina and western Virginia and into eastern Tennessee and Kentucky. And that very slow movement resulted in a great deal of rainfall, 30, 40 inches of rain common across the area as those feeder bands just streamed into the Carolina coast as the storm was moving very slowly westward across the area. So it produced very, very heavy rainfall through that area. Now, let's take a look at what we're going to be seeing for the coming hurricane season. We're looking at the water temperatures in the Atlantic and Pacific, the levels of instability, higher pressure than normal across the area can reduce the activity. We're looking at something called the Atlantic multi-decadal oscillation, which is a warming and cooling of the Atlantic Ocean that leads to different types of activity. And some of the seasons in the past that have a similar setup going into the start of the hurricane season. We call those analog seasons. First of all, what's happening in the tropical Pacific? Is there an El Nino, a warming of the tropical Pacific? If so, that tends to enhance the activity over in the eastern Pacific, and it causes increased wind shear and generally unfavorable conditions across the Atlantic basin, reducing the numbers of hurricanes in the Atlantic basin. Well, we look at the water temperatures. This is last March. This isn't the current month. This is current year. This is last March, March 17th, 2018. Now look over in the tropical Pacific. All that blue is below normal water temperatures there west of South America. And it looked like well, early on in February, it might be seeing an El Nino last year. That never materialized. It was pretty much close to neutral conditions out there in the Pacific. Now let's compare that to what we're seeing right now. A lot different, a lot more reds and oranges there, back to last year, this year. Now we're seeing that we do have an El Nino in place right now. In fact, the models are currently forecasting that the El Nino is likely going to be continuing in through the peak of hurricane season. This is one of the forecasts that we look at from the International Research Institute, showing that the mean of all the models, the red line, is well up above the 0.5 Celsius above normal in the El Nino region. And right at peak season, it's showing an El Nino in place, which would tend to inhibit activity. If we look at another prediction here, we can see the August, September, October forecast is now a 68% probability that we're going to be seeing an El Nino this year. Very slight chance of cooling in the tropical Pacific. That would be a La Nina or neutral condition. So it looks like we are going to see that El Nino, which is going to be an inhibiting factor as far as a number of hurricanes, in particular major hurricanes out there this year. Another factor is the water temperatures there in the eastern part of the Atlantic Basin, in the main development region between Africa and the eastern Caribbean Sea. Last year they were rather cool. We didn't have a lot of strong storms out there, and this year they are quite cool again. In fact, a little bit cooler than last year. So we might tend to have less hurricane activity east of the Caribbean Sea again this year. But look at those water temperatures there. And look at those water temperatures there in the Gulf of Mexico and off the southeast U.S. coast. Very warm water. The warm water provides heat energy for hurricanes. The warmer the water, the stronger they can become. So that indicates that should something move in toward the Gulf or off the Bahamas or off the East Coast, we could be seeing a strong system potentially due to the greater heat content in those regions. Now, the Atlantic multi-decadal oscillation, big group of words there, but it's basically a pattern of warming and cooling in the subtropical Atlantic, and we've tracked that down since back in the 1800s. But this graphic here shows from 1950 onwards we had warming. In 69 to 95 it was pretty much a cool water regime there in the Atlantic. From 95 until now, it looks like 2013, we were in a warm cycle, but just recently, the last several years, it looks like we may have shifted into a cooler regime there in the Atlantic. But what does that mean? In general, it means that, let me go back to the slide. In general, it means that when we have a cooler regime, we tend to have about half the number of major or intense hurricanes than we have during a warmer regime. We might have an average of about 4 major hurricanes, category 3, 4, and 5 hurricanes in a warm regime, and only about 1 or 2 in a cool regime. So we may be looking at a multi-decadal period where we're going to have less major hurricane activity. Doesn't mean that the threat is necessarily decreasing for all areas, because those major hurricanes are still going to develop and they could still strike land. But it does look like we may have fewer of them, perhaps, if this cooling trend continues into the next decade. The UK Met, the United Kingdom model, is looking at the forecast of pressures across the tropics, and we focus our attention over toward the Caribbean Sea and tropical Atlantic. We see lots of orangish and yellowish orange, and that's higher than normal pressure. Higher than normal pressure means that the Bermuda high pressure to the north is going to be a little stronger. That produces a little bit stronger trade winds, a little more low-level wind shear. It upwells that cooler water, and that makes that area less favorable for development. Analog years, the final predictor that we're going to look at, and my coworker Fred Schmoody has worked and come up with these analog years, identifying years with a similar setup of ocean temperatures, wind flow patterns, etc. And we've identified these particular years here in the final column there, ACE, that's accumulated cyclone energy, which is a measure of the total energy produced by the storms that developed in each of these seasons. It's a function of the intensity and the duration. So a long-lasting hurricane could generate 20 or 30 points all by itself. But an average for the entire season over the last 30 years or so is about 103 points. And you can see here from all these analog years that Fred has identified, it's definitely a good bit below normal in terms of the amount of energy out there in the tropics. Now, where do those storms go in those analog years? So these are all the years here. And we can see we still had some significant impacts. I personally remember, I remember all of these. I remember Agnes in 1972 striking the Florida Panhandle and then moving up the East Coast. I remember watching Walter Cronkite on the news talking about the extreme flooding up the East U.S. coast. Gladys in 1968 across Cuba, Florida, and then up the East Coast. Of course, everybody remembers that was in Florida in the southeast Louisiana area. Andrew, 1992. There are only 7 named storms in 1992, but it struck southeast Florida, Homestead area.
Yeah,
category 5.
My house, I used to live in Homestead.
Yes.
My house is gone. My house I lived in before Andrew is gone.
So David's now homeless.
Well, not exactly.
No, he's living in Houston now. But that could produce a great deal of damage there in southeast Florida. Then it moved into Louisiana, still is a major hurricane. I remember Anita for 1977 because that's the time I switched from USL in South Louisiana to Texas A&M to finish my degree. That was the first hurricane I saw there when I was at Texas A&M out in the Gulf. Category 5, very strong storm. And finally, look up in the northeast. You see Bob up there. Now, last year, all the analog years pointed to southeastern U.S., but they weren't so much indicating a more northerly threat. And Bob, in one of those analog years, struck the Long Island area and the southern portions of New England. So if we take a look at all these predictors, what do we have that points toward an active or an inactive season? Well, El Nino looks like it's becoming more likely. Last month, there was a 50% chance, now 68% chance. Odds are increasing. We're going to have that El Nino that's going to knock those numbers down. We have below normal water temperatures in the northeastern Atlantic. That's a cool Atlantic multi-decadal oscillation. That would indicate less major hurricane activity. The analog years were all quite inactive, so that's another sign there. And finally, the main development region between the East Caribbean Sea and Africa, then we're looking at decreased activity there, increased wind shear and cooler water. So that's another inhibiting factor. As far as an active season, well, we have so far, well, not really any that indicate it's going to be above normal season. The only factor that we did take into consideration with our outlook is that we have changed, or the Hurricane Center has changed the way it names systems these days. Last year, I think we had 6 or 7 subtropical storms named, and some of these lasted a very short period of time. We're now more likely to name a system well out in the ocean that has maybe right borderline tropical storm characteristic, and that's adding about a storm or 2, maybe a storm or 3 per season as far as the numbers overall. So that's bumped the average number of storms up over the past 10 or so years by 1 or 2 or so storms per season. Just the different way we're naming things than we did back in the 70s, 80s, and 90s. So our forecast for the season. Normal, and I calculated over the past 30 years, 14 named storms, 7 of them becoming hurricanes, 3 of them intense or major category 3 hurricanes, 3, 4, 5 hurricanes. Our forecast is for below normal activity, not quite as low as some of those analog seasons are predicting, but somewhere around 11 to 13. If it wasn't for the fact that we're naming some very short-lived storms well out to sea now, we might have gone closer to about 11 for the named storms. 4 to 5 hurricanes, and only 1 or 2 intense category 3, 4, and 5 hurricanes. Now, looking at the map here, I don't show any area as being above normal as far as potential threat. I see a lot of areas that are below normal, but this area here from the mid-Gulf Coast up the mid-Atlantic coast all the way to southern New England, I'd say that that area is elevated over other parts of the map here. The Eastern Caribbean, I think, will still be quiet, but just a little bit of elevation there from the southeast Louisiana coast over toward southern New England because of those analog seasons indicating that threat. And also, my coworker here, Fred Schmoody, has been indicating that low pressure would generally be dominating the central U.S. over the summer months, and the jet stream would be coming out of the southwest right up through Ohio Valley and western Pennsylvania. That is a little farther west than we were seeing last year, which might not protect that southern New England area as far as any potential impacts this coming season. And there you can see, I thought I had this animation on there. The jet stream a little farther west. Last year, that leading edge of the jet stream was right about on the coast, and that kept the storms away from southern New England. This year, a little bit farther west, so we might see activity threatening a little bit farther up the mid-Atlantic coast. And with that, I've come to the end of my presentation. That's a list of the names for this year, same list as in 2013 and 2007. We repeat the list every 6 years. And I'll turn it back over to Dave.
Well, thank you, Chris. We're going to introduce Fred here in just a moment. But before I introduce Fred, I wanted to take a moment to mention StormGeo's hurricane drills, trigger reports, and EHPPs, the Employee Hurricane Preparedness Presentation. It is the time of year, after all, when we're all looking at not only the forecast, but looking at ways to improve or even create a response plan. And integrating our trigger report into your response plan is a great way to do that. Also, getting our employees, getting your employees ready and prepared for the hurricane season is a great way to keep your business online, or to get it back online as quickly as possible after a storm. That's where our EHPP comes in. In fact, we're doing an EHPP here at StormGeo later this morning for our StormGeo employees. And our trigger reports, they dovetail nicely with StormGeo's critical weather information with the specific phases of your disaster response plan. Our drills, trigger reports, and EHPPs are really designed with your freedom to perform in mind. If you're interested in more information, or any one of the three of us, Fred, Chris, or myself, we can help. Our email addresses will pop up at the end of the presentation, or you can send an email right now to, well, after this presentation, to impactready@stormgeo.com. Now, let's introduce Fred Schmude. Fred, welcome to the microphone. Fred is our senior scientist for long-range weather prediction. You've been with the StormGeo family since 1990, so we hope you know what you're talking about.
Thank you, Dave.
No, I'm just kidding. Okay, Fred, it's all yours. Take it away.
Well, thank you so much, Dave and Chris, and good morning, everyone. Let's go ahead and take a look at the agenda for today. Of course, we're going to take a quick look at the past winter. It's been quite eventful in some areas, more on that in just a moment, but temperature and precipitations, we'll look at that. The snowfall, of course, and some of the main weather highlights during the period. Then we're going to take a look at some of the detailed long-range signals that we're looking at for the upcoming season, including water temperatures, very critical, soil moisture, and then we're going to have to take a look at those weather outlooks through September of 2019, including the 30-day, 90-day, and then the seasonal outlook out to 180 days. Let's take a look first at the temperature pattern we've seen over the past 90 days. Look at these colder than normal temperatures. Remember, this is a 3-month mean across the plains into the northern Rockies, averaging from 3 to 5 degrees Fahrenheit below normal, milder than the normal across much of the eastern and southern United States, particularly the southeast U.S. centered right over Alabama, averaging as much as 6 to 7 degrees Fahrenheit above normal. Precipitation is averaging well above normal, some very enhanced snowfall across the plains into Montana, upper Mississippi Valley, Great Lakes, even into the interior Northeast. We had some enhanced rainfall across the Tennessee Valley and northern Deep South, quite stormy conditions in California. It was drier in the Pacific Northwest and across much of the Deep South and Gulf Coast, particularly the Gulf Coast over towards the Texas region. Here's snowfall, very enhanced across much of the United States, particularly across the plains to the Great Lakes interior Northeast. Anywhere you see this yellow shading, that's a foot or more of snow. You can see it was very enhanced, several feet across the Dakotas into Minnesota down to Nebraska. Part of the reason why they're seeing all the flooding right now, because a lot of that snow melted very shortly or over a very quick period of time. Rockies, very enhanced snowfall, also even to the Northeast, only across coastal areas of the Northeast, including the New York City area, with snowfall a little bit below normal, including the Boston area. Here's some of the main weather highlights we've seen during the winter. You pick your area that you're most interested in, but you can see across the west, snow was very generous, and even had some record snow in Seattle, over towards Salt Lake City and over towards Flagstaff. California did very good as far as rain and snow across the Sierra. We had this big tornado outbreak across portions of eastern Alabama into Georgia. Even some river flooding across parts of the Deep South, the Midwest, eastern Nebraska, over towards Iowa. Even had a big March blizzard from Colorado into the plains. And we had that higher frequency of extreme cold across south central Canada into the Midwest, with a record cold into the Chicago area. And we saw that in late January. And here's some of our seasonal long-range weather signals. And what's nice about these is it does provide our clients with self-assurance to plan long-range projects and provide them freedom to perform with confidence. And so this is part of our goal with these seasonal forecasts, is the planning for any of those long-range projects. But here's some of the current water temperatures anomalies that we're seeing. This is such a key ingredient to making these long-range forecasts, and it's because of the heat capacity of water changes over a very short period of time. It's much larger, and because of that, it changes at a much slower rate. But you can see across the Western Pacific, we're seeing sinking air, and that's going to result in less precipitation across that area. I think very key is across the Eastern Tropical Pacific, we're seeing a strengthening El Nino. Chris was talking about that. Off the West Coast, this cooler than normal water may actually enhance the Pacific storm track across that area. And we have an unusual configuration across the Atlantic with cool water across the tropics and across the North Atlantic with warmer water right across the mid-latitudes. And that's a very interesting feature we'll be watching as we go through time. But what's interesting about this El Nino is it may produce some enhanced wind shear across much of the tropics, and that could result in some decreased tropical activity across the Atlantic basin this year. Soil moisture, very key. This is the current soil moisture chart. Then anywhere you see that green shading, that's higher than normal soil moisture. And one thing I've noticed over the past several years is that soil moisture is a precursor to what the flow pattern may look like. And because it's so elevated, we do think we're going to see a big dip in the jet stream down towards the northern deep south, and that could affect tropical cyclone tracks, but a potential tropical cyclone tracks as we go through time. And that's part of the reason why Chris identified the Eastern Gulf over towards the eastern seaboard as maybe a possibly enhanced area we have to watch out for some tropical cyclone activity as we go through time. Let's take a look at the outlook now. First for April. These are temperatures above normal across much of Canada into the northern and eastern United States. Cool pocket down across the southern and central plains down to New Mexico, maybe as much as 2 to 4 degrees Fahrenheit below normal. Precipitation as we go through April, enhanced rainfall and snowfall across much of the southern and eastern U.S. into eastern Canada. We do have identified and maybe enhanced risk of winter storm activity across the central Rockies into the upper Midwest or the northern Mississippi Valley, enhanced rain and maybe severe storms across the central and southern plains, deep south. So we could see some more river flooding across this area. So that's something we'll definitely be watching out for, and maybe some enhanced winter storm activity across the eastern portion of Canada, drier from the Pacific Northwest into Western Canada. Here's our outlook from April through June. Temperature outlook above normal across much of Canada into the eastern United States. Below normal temperatures across the southern Rockies and southern plains in eastern Canada. Precipitation, again, enhanced precipitation across much of the southern U.S. into eastern Canada. And again, we do have identified that enhanced risk for some late winter storm activity from the central Rockies over towards Minnesota, with maybe more enhanced rainfall and severe thunderstorm activity across the central and southern plains into the deep south, drier across much of central and western Canada. And here's our extended outlook from July through September. Cooler across central and eastern Canada, down through the central plains, higher than normal temperatures across much of the west coast into western Canada, and then across much of the east coast from Florida over towards southern New England. As far as our precipitation, as we go through the summer season, enhanced rainfall and severe storm activity likely across much of the plains into the Rockies, deep south, much of eastern Canada, and drier across much of western Canada. And you can again see that enhanced risk maybe for some severe storms and heavy rainfall across the Great Plains and deep south, and that slightly elevated risk for a tropical cyclone across the eastern Gulf from central Louisiana right up along the east coast all the way to southern New England. So it does look like potentially an active season as we go through the spring and summer. And so, Dave, that ends my part of the presentation. So if there's any questions, be more than happy to answer those.
Yes,
right
Fred,
now.
we do have some questions.
Very good.
And I'm going to leave you at the microphone, even though this is, it came in for Chris, actually, but I think this is right in your wheelhouse.
Good.
The question is, the cooling of the Atlantic, is this related to climate change, or will it influence climate change?
Well, that's actually a very good point. I know that's a hot topic in our today's world. I think what we're going through right now is just a normal change in the temperature pattern across the Atlantic Ocean. Right now we're going through a cool phase. For instance, this Atlantic multi-decadal oscillation, we've been tracking these for nearly 50 to 100 years, and you can see they go through 20 to 30-year cycles. And I think right now we're just starting to enter a cool cycle, and I think we'll also see the Pacific Ocean eventually go through a cooling cycle as well. It's just that both the Atlantic and the Pacific were in a warm cycle at the same time. The Atlantic now starting to cool, and I would expect the Pacific to start to cool as we go through the next 5 to 10 years.
Excellent. The next two questions are for Chris, so we'll slide Fred out of the way and move Chris to the microphone. Chris, the forecast is for track or related to track. Is that a 3-day forecast or a 5-day forecast?
You're talking about track TRAC?
TRAC.
That actually we have on your web portal a 5 and a 7-day version are displayed there. We are in-house producing a 10-day version because the European model goes out, and the Canadian and American go out to 10 days. So we're not producing that on the web page, but we are on the web portal producing the 5-day guidance and the 7-day.
Thank you. Now, another question. Would you forecast below average ACE, accumulated cyclone energy, would you forecast below average ACE that is more in line with the analogs relative to the seasonal storm counts, given the new naming convention? It's not really a convention, is it?
Well, the new naming convention, we talk about them naming weak, short-lived systems, which might get less than a point in ACE. So that doesn't really come into play. It's a factor of how long. Last year we had a little bit above normal because Florence was out there for a long time as a strong hurricane, and that gathered a lot of points. Michael, not so many because it started right in the Western Caribbean Sea. But in general, as far as the ACE, I'm not looking for around 40 to 50. But Fred, what do you think? Around maybe 80, 90, a little bit below normal. Normal about 103, 104. So we're going to a little bit less, but I don't think right now yet we're going to go down as low as some of those analog seasons.
All right, well, I'm looking, and we're pretty much out of time. We're right on target. I like to run this about 30 minutes, and sometimes the Q&A runs a little bit long, but I think we're in good shape. So we're going to wrap this up. For those, there have been several questions actually asking about the presentation itself. So we will send out a recording probably tomorrow. I might be jumping ahead of myself a little bit here. Let's see. Yeah, I think that's it. Going through some notes, last page. All right. If you do have any questions, you can contact the three of us here. Our emails are all located. Also, information about info@stormgeo.com will get you more information as well. The next slide, Chris, is our next webinar. I mentioned that at the start of our presentation. We'll have Nathan Stanford. He's the manager of our Stormwatch team and cross-industry. Matt Hallworth is our severe weather expert, and Justin Patrizis, as I mentioned earlier, he's joining us right now. He'll be part of that presentation next week as well, so that'll be fun. All of you attending, okay, here we go. I jumped ahead of myself where the recording, we'll get this next week, or not next week, but tomorrow or the next day. We'll have that emailed to you for sure. And for the rest of our webinars, we've got some scheduled out through the rest of the year. Check stormgeo.com/events for more details. And that's all we have for you. So I will wrap this up. Thanks so much for joining us. I'm meteorologist Dave Gorham here in Houston for Chris and for Fred and Justin down there at the end of the table. Thanks, everybody. We appreciate you joining us. Bye-bye.